3 or 4 weeks ago I picked up a Stuart 2.5A engine, a model engine. In fact, it's not a model engine, it's a full size engine. I brought it home, I put some compressed air on it, and it would only run in one direction, and it wasn't running very well. It had a terrible knock on it as well. I hadn't got a great amount of time myself, so what happened was my friend Bob got it. He's took it away to his workshop, stripped it all down and found several issues as to why it won't run. So Bob's actually come here tonight, brought the engine, and he's going to go through it and discuss some of the things that were found wrong and how we're going to go about sorting it out. How you doing, mate?
How you doing?
Come see you right away. Yep.
Yeah.
Hey Bob, there's our bench. Carry on, mate.
Loads of fun. John gave us a shout out about his engine and said it was only running in one direction. And me and him thought it would have something to do with the valve timing. As the Stevenson link on, which I've disconnected. But as I've explained to John, and John's at the same agreement with me, it's had at least 2 people at it, because the machining from all this, the cylinder, well, not the machine is absolutely fantastic until you get to the valve chest, and there's loads of major issues in the valve chest. So that's all it loose. So I've taken the valve chest off. The first issue I found is with his valve. Now, I've actually ground these faces. I've took it into work in my lunchtime. I've ground both faces. But originally the valve face wasn't touching the port face. Now, I'll take this off. These ports are now equal. They're equal distance from top to bottom. Originally they weren't. They're all on an angle, like where they were being cast. So I've carefully, with a file and the square, I've squared them up, but they're now equal distance. All this helps the engine to run via timing that both ports is equal. So the stroke of the valve is equal both sides, not one's higher than the other. Now the valve, I'll turn it round and put it in that way. I think John can do it in his camera. It's actually being made all wrong. It's been over machined, and what they've done is they've stuck 2 pieces of brass, one on the top and one on the bottom. And if you notice, the top one's thicker than the one on the bottom. But the main problem, what I think the main problem is the valve itself is not square. What I call the valve nut, this bit here, what holds, this is your valve rod, this is what makes it go up and down. One, to me, there's too much play. There has to be play, but that's too much play. But it's not in the middle, it's off centre. So on one stroke, it's got to go further than what does on the other stroke to cover the both ports, because it's off centre. Plus, as John said, it had a nasty knot when he set it away. But the clearance on all this is not dead square, it's just badly machined. Want to square it up, but the nut is actually hitting, or the valve face, the valve is hitting bottom and top of the valve chest. Now I reckon one of them was the knock John was getting when he was trying to run it. So I'm going to make a new valve. I'm going to square all this up. I've made new joints. Now, the other issue was, turn it round, I don't know if John's camera can pick it up, was these ports. I've never done an A5 before, but the piston was covering these ports, and I thought it shouldn't really cover the ports. But through a friend of John's, we've managed to get Mr. Keith Appleton, we've getting some information, and yes, the piston does cover both ports. So that's not a problem. What's been the problem is the valve. It's just so badly made that it's not sealing, it's not right in the right length, it's stroke where it's supposed to be. And because I've ground these two faces, this face and that face, and I've polished that face, that was all roughly machined. The valve is somewhere near the port face, but it's still not right. By the time I get a gasket on, or a joint as John calls them, that face is nowhere near where it needs to be. So I'm going to have to make a new valve, then we'll get it going from there. We've got some information on the bottom concentrics. John's friend, Mr. Keith Appleton, who does these all the time, he makes these in two separate halves. Now I don't know if it's made as one or it is made in two separate halves, because I've never had this a bits. I don't want to take the bits till I get the valve problem sorted out. Once we get the valve problem sorted out, then we'll concern with the concentrics. If you have to make two separate ones, then we'll make two separate ones. But I'm just hoping by making a new valve to the dimensions that we're getting off Keith, we'll solve the problem. Like. So apart from that, it's very, very well made. It's just when it's come to this last bit, so it makes me think somebody else is getting the engine, because the rest, this machining all on here and the marks what was on these faces doesn't match the rest of the cylinder or the rest of the engine. So we're going to go from there and we're going to say what we can do. So what we're going to do is we're going to make a new valve nut and discuss it with John, and I'm going to make it out of bearing bronze. Originally it's made of cast iron, but it's going to, John is going to run it on steam, but it's going to be more of an ornament than actually being used, if you want to put it that way. So to me, making the one out of bronze which won't corrode will be better off for the valve face than the valve itself. Now it didn't have any piston rings, so John's going to try and source some piston rings. If not, I'm going to make some new piston rings, but not out there cast iron, whatever they're supposed to be made out of. I'm going to make them out of nylon, bearing grade nylon. Again, it's just that they'll never rust and they'll never knock the cylinders up. So we'll leave it at that and we'll catch you all later. Thank you. Bye.
This is a punch or a stamping tool of some description. I think it's got something to do with leather, and what's happened, it's made out of a bit of best quality Chinese cast iron, and it's snapped clean across there. I think it's snapped because they've tried to use it without putting a securing bolt into there. Just pivoted, broke. If you used a steel rod, it would crack. You could use a pure nickel rod, that's for repairing cast iron. But I find that using silicon bronze, it has a little bit of stretch in it, and it allows things to move a little bit as it cools down. Not always, but I think it'll probably work in this situation. You can also get a bit of reinforcement in the bottom somehow. I'm sure I'll be able to do something with it, but the first thing is to do a bit of damage with a grinder. I've laid this out quite deeply and I've got it clamped onto a nice bit of solid plate so it won't distort hopefully when we weld it. So the idea is to run some silicon bronze into there, then I'll probably turn it over, I'll veil the other side out and do the same on the other side. I'm not quite sure yet, but I'll definitely be going to put a reinforcing plate underneath it. I'll put a bit of preheat on first, a little bit of oxypropane just to take the chill off it before we weld it. This is the setup I use. It's a CK torch, a water cooled torch. I've got a number 8 straightforward cup a 2.4mm blue lantherated tungsten. I use them for everything now. This is a setup that I use for silicon bronze on cast iron. I'm in program number 5. I'll go through the menu and show you what we've got. Start at the beginning. I've got no pre-flow gas, I don't need it because I'm using a foot pedal. No upslope because once again I'm using a foot pedal. I've got the main welding arm set at 170, I probably won't need all that. AC balance I've got set right down to 10%, just a little bit of cleaning, it does help especially on dirty cast iron. Frequency I've got at 70. Post flow, that's gas that comes out when I finish welding, 9 seconds just to keep things clean. And I'm on AC, advanced square wave, using a foot pedal, high frequency start, and there's no pulse involved. Right, that's the finished weld. That's as welded, it hasn't been dressed up. You could run a die grinder across there and make it look very pretty, I suppose. So we'll let this cool now naturally, then I'll turn it over, grind the back out and fill the back in, and that should be a pretty good repair. I put plenty in here so I can file the top of the bolt holes flat. It's cooled down now, nice and cool. I've taken off its support bracket and I've ground the back out of the die grinder, and you can see I've broke into, that's the bronze weld build-up material there. So I'm just going to fill that in with more bronze weld, machine the base flat, and that should be a decent enough repair. Right, that's a finished repair. It's lying nice and flat, there's no wobble or shake, so it hasn't pulled during welding. I filled the inside in as well. There's little bits here, but as long as it's bolted down, as long as it's got that screw in there before it's used, it'll work perfectly alright. But it's been used without that screw in and it's gone like that and snapped off across there. Once again, it's just time to say thanks for watching, thanks for subscribing. If you haven't subscribed, please do so, it does make a big difference. I really don't want to get to 100,000. Anyway, thanks for watching.